So I already did a bit of an intro about myself. So yeah, I've been with LauzHack since the beginning, doing a PhD in computer science. But before I did the PhD, I actually worked in industry a bit. So I was working at a company called Sonos. I don't know if you know them or not. They're kind of a high-end version of LauzHack speakers. So there I was working on speech recognition technologies. And a lot of the stuff I show in this workshop on GitHub, and also for the one next week on Python are some, you could say, industry tips, which I picked up when during internships, when working full time, and some of the things that I try to use also in my PhD, which helped me a lot to kind of manage multiple ongoing projects at the same time, which is probably the case in a lot of your studies as well. You'll have multiple projects at the same time, and if you can help yourself to organize them well and also to collaborate with code in a nice way with your classmates or colleagues, it'll help you to context switch between those projects, and that's what we'll see that Git does a really good job at. So a bit of an outline for today's talk. So we'll look at the concept of Git, what is GitHub on top of that, kind of the basic steps of installing, setting up a project. How would you then push code, which means to upload, pull, to download? What are the different features on the GitHub website? And how would you then collaborate with colleagues, classmates, friends on GitHub itself? So how many of you already have a GitHub account? Okay. How many of you are comfortable with, let's say, Git commands on the terminal? Okay, couple. How many of you use an IDE like VS Code, PyCharm to do Git? How many of you just upload files through Git through the web interface? That's super convenient too. Okay, so we'll kind of touch upon those different aspects, and maybe on this last one, how many of you are comfortable with doing merging and resolving conflicts on GitHub? Okay, so that's what that's, I guess, the topic that most people are interested in. We've done this workshop like 4 or 5 times, and this is the one which hopefully can give you some insight, or at least some slides in a video, which you can then come back to when you get into such conflicts. And next week I mentioned, yeah, we have this Python workshop. So these same slides, which you'll find after the workshop, are the same ones for the Python one. So they kind of like follow up with each other. And there we'll just see some kind of pro tips in Python DevOps, or how to improve your workflow in Python. So the slides, if you really want to follow along, they're at this QR code. Read the docs.io, and then Google Slides. That will also take you there. Let me just copy that link actually on the slides. That will help whoever wants to do either of them. All right. So GitHub, what's the difference? First of all, let's start with the basics. So Git is what we would call a version control system. So it's trying to keep track of what are the different changes that take place when you add lines to code, remove lines, when you add files, when you delete files. And it's trying to keep track of these differences. And Git can be used remotely. So these are terms I'll use often. It can be used remotely on a server, or it can be locally on a computer. So when I talk about remote, I'll usually be talking about the github.com websites, or maybe some cluster or cloud machine. When I talk about something local, I'm going to typically be talking about, okay, our computers right here that I'm typing on. So that's what Git is. It's kind of a protocol for keeping track of these file differences. GitHub, on the other hand, is a platform that uses Git, and it essentially just provides an additional interface on top of Git so that it's a bit more easier to use. So for example, I mentioned using terminal commands to work with Git. That would be the most bare bones way to work with Git. But what GitHub does is they provide a nice interface on top of that, so that you can do all of these terminal commands, maybe through graphical tools, or if you did it through an IDE, there'll be like clickable buttons that you can use as well too. So all of these tools are trying to just kind of do a wrapper around Git. And GitHub is just a website where we can kind of remotely host these different projects. So why would we want version control? That's my question to you now. Why would we want it? Yeah.
Old versions when you made a mistake.
Yeah, maybe you found a bug that you somehow introduced. It's nice to be able to go back to previous version. What are some other useful things? Yeah.
Very practical for like collaborations where multiple people are doing the same, working on the same things. So
yeah, so then yeah, we can also have some sort of idea of who did what, and then what we'll see is we can do this thing called branching, where people can work on separate things, all based off of the same code, so that you don't have to wait on someone else to implement something sometimes. Any other questions or thoughts? Why could it be useful? Yeah.
Making sure that you have a history of changes.
Yeah, it could be a backup of the changes to go back to another version. So I mentioned something here about, so this is specific to Git, not version control, because there's different types of version control. Git is only keeping track of the differences. So what's nice about this is that, let's say you have a huge code base. Maybe for some reason it's megabytes of size. Imagine if you were trying to keep track of thousands of versions, right? Maybe it gets to tens or 100,000s. If you were keeping track of the full code base, it would start to get really bloated, this version control. The one nice thing which made Git super popular is that it's only keeping track of differences. So each time someone makes a new change or there's a new version, you're not going to do a whole copy of that new code. You're rather just keeping track of that small difference. I guess a funny example that I like to give to people is probably you've been in this experience, we all have, where we're sharing code to our classmates or colleagues, and we have let's say a folder we call V1. We call it V2, V3, and we're sending these files back and forth. Who's been there? Who's done that before? Yeah, okay, most of us. So Git kind of helps avoid that bloatedness of files. So that's okay. We only keep track of those differences, and then there's this remote place where all of that is being kept track. So yeah, I mean, we touched on all the bases here. So we have a searchable and log essentially, where we can figure out where these changes are made. And as was mentioned in the back, multiple people can work, let's say, on a similar file or code base, branch off, make their changes, and then we're going to try to figure out how we can branch it back together. And it's that branching back together what causes those conflicts that we'll see in a bit, these merge conflicts. So there's alternatives to GitHub, and there's many reasons why you may or may not want to use GitHub. Some of them could be you want something open source, something that's free, something that's tied maybe to your institution. For example, if you work in industry, maybe they'll use something that comes with a whole package of tools, things called Atlassian, which comes with Bitbucket, or they may use different versions of source control. So you can't use GitHub, you'd have to use another type of source control. But yeah, there's different alternatives. GitHub is one that just got super popular, maybe because of their really cute logo, which is like a octocat, but also they made it really, really easy to use. So yeah, just some of the features. So some of the features we'll see, which I personally like on GitHub, are the features that they have for doing code review, which means, okay, let's say you're trying to figure out how to combine code together. They give a nice interface to discuss code. Yeah, that's one feature I like on this side of things. So in terms of setup, if you haven't done already, you could go through these steps while I talk. So if you follow the link in the slides, this will take you to the instructions for installing Git on Linux, Windows, or Mac OS. And then the other important thing, if you want to do stuff along with me, is to make an account on github.com. I think a lot of you already had, but yeah, otherwise it should be rather quick to do it. And one thing which I should put in the slides is when you go on GitHub, there's something called the Student Developer Pack. How many of you are familiar with this? Okay, let me just point that out. Otherwise, so if you look this up, the Student Developer Pack. So you may not get the access right away, but if you can get it for next week, if you come, that'll be nice. So when you sign up for it, essentially it's going to ask you for your student credentials. So you can do, I think, a picture of your Cami Pro or like a PDF from IS Academia. And then it gives you access to all sorts of features. And I think the most interesting one is essentially something called Copilots, which is to help generate code. So usually it's a paid service, but within your IDE or other locations, you can use Copilot for free.
But now everyone can access Copilot for free.
Oh, it's for free for everyone now. Okay, nice, cool. So I stand corrected. But they have other nice stuff that could be free. I don't know, but cool that it's free. I guess, yeah, there's so much competition now. They don't want to lose customers. All right, so let's look at the first thing. So one thing that I often do when I'm starting a project from scratch is actually I'll do it directly from GitHub just to kind of get all the Git setup kind of out of the way. And what's nice about doing it from GitHub is that they provide a neat little interface so that you can initialize your project with common files that you would have even if you didn't have that project on GitHub. So if you go to github.com, if you're logged in, you should see this green button here, which is this green new. If you press on that, it should take you to kind of a form which you can fill out to create this project. So it usually suggests some silly name. In this case, it was upgraded potato, but obviously you want something that's more representative of your project. And usually in this context, when I'm starting a new project, it's probably going to be a project that is really scrappy, kind of it's not perfect by no means. So they have this nice option where you can pick a private repo. So only you or collaborators can have access to this. So you don't need to be ashamed of let's say, scrappy code that you publish online. And then the next parts are the things that I find super useful when using GitHub to start a project. One of them is to create something called a README file, which is essentially kind of becomes the homepage if you make your GitHub repo public. So I'll use this term repo kind of interchangeably with project. Feel free to raise your hand if I say term that goes over your head, because I'm too used to working with this that I may forget that which things are application specific. So a README will be kind of like your homepage for your repo, your project. And then usually that's where you would want to put important information about your project if you share it to other people, but also even for yourself, because maybe you forget how to run a certain command, how you install your project. So that's where you would kind of put all the important information. The next important thing is a git ignore file. Does someone know what the purpose of this is? Yeah.
When you don't want to push some files, you put them in.
Exactly. So essentially, GitHub is going to try to keep track of which files have changed. And if you put a file in the git ignore, it will ignore that file when giving you this kind of summary of what has changed. So it's a useful file, for example, to prevent things you wouldn't want to keep track of or to upload. Can anyone think of what could be things that you don't want to upload to your repo, to your project? Someone else? Yeah. API keys. Yeah, you don't want to. So API keys essentially it could be a password for a particular service, an online service. For example, if you use OpenAI, ChatGPT, if you want to use it in a programmatic way, they'll have what's called an API key to use it, and you don't want to publish it so that everyone burns out your credits. What else would you not want to publish? Yeah.
It's like private files. If you have an Excel file from which you could take the data.
Yeah. So private files. Following along, or you have something in the back, yeah?
And some configuration files, like for example, game engine sometimes produce some configuration files that are actually not important.
Yeah.
But and they change like every time someone that runs something, so they keeping track of them might be problem.
Yeah. So essentially, if I'll rephrase a bit, sometimes your software will generate or create compiled files. And since those are going to be created from that source code anyway, you don't need to share it, because when someone runs the code locally, it'll be compiled. Maybe one reason where you may want to upload it or to push it to GitHub is if it's a really clean version of that project, and you want to make sure someone can have that without having to do the whole compile build process. But yeah, usually you'd want to ignore such files.
Like the VSL folder, for example, .ysl folder.
Yeah. So configurations for your coding environments. Another thing kind of linked to what was said at one point there in the middle. So most GitHub projects, they have a limit in terms of the size of that project. I forget if it's 2 gigabytes or 200 megabytes, something like this. So imagine if you're doing some machine learning project where you have huge amounts of data. Usually you wouldn't want to include that in your GitHub repo. It's going to take up so much space. Usually what people will provide is another link to download that data. Maybe you'd upload like a sample data, but usually you would avoid putting huge amounts of data on GitHub. Any other thing that someone has an idea of else? Okay, so there's so many different files that you'd want to be ignored. And what's useful about this interface from GitHub is that depending on the programming language you use, like let's say Python, it knows what are the common files you would ignore from Python. So instead of having to manually write that file yourself or find something online and copy it, GitHub provides all of these templates. So of pretty much all the popular programming languages that you could want. So it's a nice little feature then to initialize your project with this. So yeah, so when you go on that drop-down menu, you essentially write your main programming language for your project, and then it'll initialize it with the templates. And then you can always manually add files later on. The next thing is a license. So how many of you add a license to your project? Good. Why do you think you should add a license to your project? So is it okay to use software without a license? So as an individual, it's probably okay. It's not going to be a huge deal. But if you're working for a company, they will pretty much never let you use a software without a license, because you don't know what conditions that software should be used under. So it's good to add a license to your software. So especially if you're okay with anyone using it, the most common one is the MIT license. Then there's different variants where you can say, I don't want it for, let's say, commercial use. That it's, oh yeah, our alternative is good for, you're okay for research purposes, individual purposes. But this is actually quite an important thing, which people maybe overlook, but it's good to add a license so that it allows other people to use your code. Especially people in industry, they'll think about it more that, okay, I won't use this code if there's no license on it. Or you can always give specific users different license, but it's good to just have like a default one on your project. Yeah.
What's the purpose of this? I mean, it's just a click of a button, right? So
yeah.
How big of a change does it really have? The code would be the same.
The code, the code is the same.
Make malicious code and put a license on it. And
yeah.
Anyone else could use it, right?
Yeah, of course.
Like, yeah. What's the value of adding a license?
So no one will use your code if it doesn't, or no one in industry will use your code if it has a license. If you want your project to grow for people to use it, actually, you shouldn't use a software just off the shelf without a license. So if your purpose is for other people to use it, you should add a license to explain what are the guarantees, whatever limitations of the software. Most people don't think about it, but you could potentially get into legal trouble more on the case of if you use a software that doesn't have a license. Yeah.
Yeah. So my question is like, I don't see the added value because it's just a click of a button, and the license could say that I follow the procedures and I don't follow them. How can people make sure that I follow the actual license? Okay,
so how do you know that a company doesn't just take a software that was meant for non-commercial use? You mean, for example?
No, I don't see how this license adds value, because there's no check in your actual code. Like, let's say the license says this code works perfectly, no bugs, no errors, and no malicious code. But then I could go there and change it as I want. The license would remain the same, right?
So who's responsible for everything? You, the person who created the software, or the one who's using it? Then in this case, you as the creator of the software.
Great. I just don't see the.
So you don't want to give guarantees? Is that why?
No. It's just I don't see all those guarantees of value. There's no safety checks, right? I can say that my code is perfect, but then it really isn't. I mean,
most software will have a license that says, "Oh, we don't protect in this case, or we don't guarantee anything." But it's more for the fact that usually people are using GitHub to share software. So if you don't put a license, no one is going to. If you want your software to grow to have users, it won't if you don't have a license. You have something to add? Yeah.
Say you're writing some software, you write some code, and your code ends up being used in an attack of some sort. And when there is an investigation that is done, let's say that people end up finding out that you wrote this code. Having this license, like what the MIT license says is, if you read it, it says, if you use this software, you use it without guarantee. Like, I will not provide any indication that this code is good. Like, this code, use it however you want. The MIT license says use it however you want. You can use it for whatever you want, but if it breaks, it's not my fault. So it's it's like it doesn't give a guarantee that the code is good. It just always uses legal issues if it could happen.
So I understood the license was adding guarantees.
Yeah, yeah, it's like it doesn't.
Or saying you don't promise guaranteeing. So
Yeah, it's like it doesn't give any information about the quality of the code. I can write some terrible spaghetti code and slap a license on it. It doesn't matter. Yeah, it's like it just gives. It just protects you from legal requirements.
yeah, but next week we'll see some things on how can you show your code works. Like how would you do something called unit test to kind of let's say prove more on the functional aspect of the code. Yeah, the license doesn't talk anything on the functional aspects of it. Yeah. I think there was a comment on the back. I don't know if you wanted to add that. It's all okay. Okay, so if you're unsure about the license, you can always go, there's this webpage that I think GitHub links to as well. In general, in research, academic, university context, MIT is a good one. If you're in a company, you'll probably want to check with, I don't know, your legal or HR team, what's the best one. And when you're looking for projects for software to use when you're working in a company, this is something to be wary about. You don't want to have built up a huge project just to realize in the end, oh shoot, we can't use this software because it depends on something for non-commercial purposes. So after you fill up all those different steps, then just a simple click of the button to create that repo. And now it'll take you to the home page of this new project. So you'll see it's private because I initialized it private. We'll see these 3 files that come up here. And this README was initialized with just the title, which corresponds to the name of the project. Here we'll see the MIT license where you can click on, then read the limitations, guarantees, and whatnot of the license you've picked. And yeah, that's in that way you've already created your project. Yep.
Another little detailed question about the license thing. If you're using somebody else's code or project and the license gets changed, do you get notified of that or anything like that, or can they just change the license anytime they want?
They can, but that's the nice thing about the Git tracking is that you know that at this specific version of the code, it had that license. So about them retroactively changing it, I think that's kind of hard for them because they already made that promise that with this commits, I don't know if you.
Yeah, it's basically like the license in the end, it's a text file. Like you can see there, it's a text file that's in the repo.
Yeah, it'll be with the project files that you've downloaded, and it'll have their name, the date. So once that's public, it's hard for them. I mean, I don't think they can go back on it.
If you download the software with a specific license and they change it, and you don't update it. Well, you downloaded it at a point where you were allowed to use it, and the version that you have, you're allowed to use it. You have to set you're allowed to use it, and if they change it later, like you can literally prove that at this point you have this license.
And on the other end, like once I was working on a project where we didn't have a very permissive license, so people asked us to make it more permissive. So then we changed it. So then from that version on, then they could use that software. So when in doubt, you can always just ask the creator of the software if they can do a specific license for you. The one that's on GitHub is kind of like the default one, but they can always send you a version with a different license. Any other questions on this? All right. So now on actually using this, okay, rather useless piece of project for now, but just to get an idea of when you're on GitHub, you see your project that you like, how would you download it? And one term that we'll use for this is, okay, downloading it for the first time, we'll call cloning the project. So essentially the command will be something like git clone, and then you'll typically provide a URL. That would be if you're working on the terminal. On your IDEs, they'll have different ways of cloning it, which we'll see. So one which I would say is a very easy way if you want to get started, is something called GitHub Desktop. So I'll go through 2 different interfaces. I would not use this one, but I'm still going to just present it for different options for those purposes. So GitHub, they have a software called GitHub Desktop for essentially managing your different GitHub projects. So there's the link for Windows or Mac OS. And essentially, when we went to that drop-down menu on the page of our repo, there was this option open with GitHub Desktop. So if you click on that, it should open, say, a pop-up menu, which will say, oh, which application do you want to do it with? And essentially, it would be GitHub Desktop if you have it installed, and then it would clone the project. So this is a very easy way to do it, but the reason I wouldn't recommend this is because GitHub Desktop is only really serving one purpose, just for doing version control. You can't do any coding on GitHub desktop itself. You can't edit the files. It'll just tell you which files have edited, and if you want to upload or download them. What I would recommend instead is using something called an IDE, so an interactive development environment, such as VS Code or PyCharm. So here you can see downloads for different OSs. JetBrains also makes a bunch of really nice IDEs as well. For this workshop, I'll show VS Code. So yeah, here are a few options as I mentioned: VS Code, PyCharm, Replit, which is more browser-based, Spider. Now with all these AI integrations and chatbots, there are a lot of IDEs that try to integrate LLMs directly into the IDE. For example, something like Cursor AI. VS Code is a good one. It's been free with a lot of great features for a while, and essentially a lot of these extensions like Copilot, either they'll be paid or free. So it's a nice one with a quite big community, which is why it's quite useful in case you get stuck on different features. A simple Google search typically shows the answer. So why would you want an IDE? So on top of the version control, which we'll see in a bit, there's other useful aspects with regards to your actual development process. So it will highlight the syntax according to your programming language, and it just allows a lot of just simple navigation between functions and files. So we'll see that more next week, but that's just kind of motivate why it's better than just GitHub Desktop. It adds all of these other features when you're coding. So don't make your life complicated. Get an IDE. Who knows this person? I don't know if you guys are too young for this. Okay. Avril Lavigne. Yes. Okay. So when you're on VS Code, you open VS Code, they have this option where you can either open a local thing that you've already downloaded. For example, if you did git clone, or they have this option, which is clone git repository. So if you're on VS Code, this would be one way that we can now clone or download this project that we've created. So when you click on that, you can directly provide a URL or git clone from GitHub. Both options are really the same. You'll essentially just need this kind of formulation of username and repo name. And then it will ask you, okay, or it'll say that I've cloned it. Would you like to open it directly now on the project? And yeah, you can press open. And maybe it'll also ask you where you want to download those files. So one thing I do, I mean, it's personal preference. Maybe Adrien has another thing. I usually have a GitHub folder on my computer, and then I just put all my GitHub repos in that. Maybe you organize your projects differently, but yeah, that's kind of how I do it. Do you have a different way of organizing how you download Git projects?
Well, personally, I'm working using GitHub, so I'm pretty much doing the same before. Another reason is because I have you're going to talk about SSH key.
Yeah.
So I have, we'll see that's more later, but I have an SSH key for GitHub, one for GitLab. And so I just have the config file that says if I have repo in the GitLab folder, then it's going to use this SSH key, otherwise it's going to use this other SSH key. So it's just for that reason.
So SSH, we'll see in a bit, is just a way of kind of authenticating who you are. So maybe Adrien has a work account and a personal account. Maybe that's why you have different keys, I guess. So yeah. Okay, we'll see that in a bit. So don't worry if SSH doesn't make so much sense. Okay, so we open the repo. That's what we're doing now. And okay, that's essentially the process through a tool like VS Code. Let me show you the more intermediate way, which can be very useful sometimes if you don't have a computer with a screen. If you just have access to a terminal. So I would call this the intermediate way, which is through the command line. So when we do that drop-down menu, there's these two options, as Adrien mentioned. He mentioned one of them, which is SSH, which is the one I would recommend. And then there's HTTPS. So just two protocols for kind of authenticating online, essentially. And essentially, you would just click on that copy button, and we would take that as part of our commands to download the project. So, yeah.
Can you go back to the previous slide?
Sure.
There is also this option on the right of SSH GitHub CLI. So if any of you are confident with working with the terminal, GitHub has a command line interface that you can use. And I don't use it personally, but I know that it works well. So if you want to check it out, it's there.
That's like their own terminal window, right? You can download. So
it's not a terminal window. It's more like
a command.
Yeah, it's command line. It's just an executable that you can call from the terminal.
Okay. Is this something? Because I think when I was working on Windows computers, it would be useful to have this because you don't have the typical Linux commands on term.
Yeah, also I've never used it, so
Okay.
I can't say much about it.
Okay, so it's a fourth way of doing what?
You can also like manage issues, manage you.
Yeah,
like,
that's the
post
thing.
name,
Like
Okay,
don't be just limited to GitHub.
you can
Okay.
manage pull requests, you can manage GitHub actions.
from the command line.
Yeah,
Okay,
yeah,
nice.
It's
Okay.
like GitHub in your terminal.
Okay, so yeah, if you're comfortable with the command line, there's this. As you'll see, when we talk next week as well too, or with open source in general, there's like 10,000 ways to do the same thing, and essentially it comes down to personal preference, what works best for you, but also for your collaborators sometimes too. Okay, so just this difference between HTTP and SSH. So let's say the old way, which they still support, of cloning repos, of exchanging with GitHub, was HTTPS, which is one protocol. Now they're slowly pushing people towards SSH, which is more secure, and they really try to push people to use this because of the better security that it offers. And the idea, the way that your workflow would have been before, so we created this private repository. So if you try to do this git clone with HTTPS, it will ask you for, okay, what's your username and what's your password? Because why would it, if it's a private repo, it doesn't want to just let anyone download this project. So it's going to do this kind of double check to make sure, okay, you can actually have access to this. SSH has a different way of essentially doing this authentication. It works by having what are called kind of a pair of keys. So essentially, I will have one key on my local computer, so here, my machine, and then there will be a key on the remote computer. And essentially, when I make this request, it's going to ask me for that public key and do some computations between the public and the private key to make sure, okay, you are who you are and you have access to this. And what's convenient about SSH is that whenever you do these cloning or commands on GitHub, you don't have to enter your username or password. It requires just this initial setup in the beginning, which sometimes throws people off, but it's worth it. And then also for some projects, GitHub won't let you use this method for contributing to the project. So in general, I would recommend, okay, use this approach. So I'll show it in just a bit, how you set up those keys, because it's useful not just for GitHub, but for other projects, other setups that you may have. So the process then would be, okay, you do this first time generation of that key pair, which I'll show in a bit. You'll copy, usually you create these keys on your local machine, so on your computer. So then I'm going to share this public key. I think I said something wrong before. I'm going to share the public key, not the private key, to GitHub. So the public key is what you share, hence the name public. And then you can run this command that was under SSH. So git clone that repo. All right. So let's look at this first step. So maybe you can follow along while I do this, so that you can already have this key pair locally and do this setup for future purposes. So on the slides, I provided this link, which if you go to that link, it will take you to a page that you see here. So if I click on it, you'll see that. And then it will go to your corresponding operating system. So here's detecting for my computer, if you're on a Windows, it'll go on the Windows, Linux, and Linux tab. Let me just go back to the slides. So from this page, the commands we're interested in are, I think it's the link I shared. We're going to create, identify, sorry, I think I'm missing the slide for that, but let me go to the page so it's clearer. So when you go to that link, essentially, you'll want to open a terminal. That's the first step. Copy and paste this text, but put your email instead. So the email that corresponds to your GitHub account. And then just walk through the steps. And pretty much I just say yes to everything. And just keep in mind where it stores this public key. And you don't need to put a password for this key pair. So how many of you have done this type of setup before? Okay. So we'll just give a bit of time for the others to do it. So it's going to create that pair, ask where you want to save it. You can just take the default, and then you don't need to put a password. And then the next useful bit is we're now going to copy the contents of this file to GitHub. So from the terminal, you could use this command from Mac OS, this one from Windows, or this one from Linux. either, depending on the command, I think maybe you'll print out the statements or it will copy it to your clipboard. But we're going to want to take those contents. And then now we're going to go to GitHub. Under settings, so from the drop-down menu, you go to this option, this menu on the left-hand side, SSH and GPG keys, new SSH key, and then you can put whatever name you want for this SSH key. So it can be my laptop or server 1, Raspberry Pi 2, blah, blah. And you're going to copy the contents into here, essentially. And it should typically start with one of these things that it says here. I think for me, it typically starts with SSH dash blah, 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 or SK, sometimes I see blah, blah. Okay, and then once you've done that first setup, then now we can run this git clone command with your private repo or with whatever public or private repo that you have in your account. Any questions on that? All right, so now I don't know if you created a repo along with me, but maybe you've done that, and now you've cloned this repo after setting up your SSH keys. Now let's see how we can make changes to our GitHub project. So how can we edit files locally, so on our computer, and then push them remotely to GitHub? So the general, let's say, step process that you can keep in mind when you're working with something like Git is that I'll be making my edits like normal, like you've probably been doing already in your projects. And then there's going to be this 3-step procedure for uploading them to GitHub. I'm going to add whatever is changed. So there's this add step. There's this commit step, which is essentially kind of giving this unique ID for the changes and also maybe describing what those changes are. And then I'm going to push or upload those changes. I put an S here because maybe you do many commits and then you can push multiple commits. And similarly here, you can change multiple files or just one file. You can commit one file or many files. So and we'll see this more concretely. So in my upgraded potato project, you can do the same thing. You can create a file called python.py. And I wrote just like kind of hello world type of statement. I just said print, hello world, my name is Eric, how are you? So I already had the file in the project, but let's assume you already had it. So this is the before. So in this example that I'm going to show, I'm going to edit this file. So here, what did I change? It's actually my question to you. What did I change? Let's count the number of changes. Yeah. The W is lowercase. That's one change. What else? Someone else. Yeah? Yeah, period turned into a comma. What else changed? Someone else. Yeah? Yes, so there's also a new file here. So it comes up in green. So this is some useful stuff that we see here. In VS Code, so it depends on your IDE, we'll have this green highlighting for a new file that's been created, yellow for something that's modified. So that's what we see here. M for modified, U means untracked. So GitHub doesn't know about this file. And one way I can also count the number of changes is actually by looking at this icon here. So on VS Code, there's these multiple icons, one of them being for source control, essentially, and it's saying there's been 3 changes. So we can see the number there. And then when I click on that icon on VS Code, then I can see what those individual changes were. Oh, actually, there was a 4th change, I think. So it counted the W and the comma as a single change because it worked on a line basis, the changes. So actually, the other thing that changed, which maybe you didn't see here, was I deleted the README file. I even forgot about that. So that's what's nice. When you go now on this source control tab, you can then see everything that changed. So here, there was this one line that changed, but yeah, as we pointed out, there was 2 parts of that line that changed, but that counted as one. A new file was created, and then this readme.md was deleted. So even I forgot what was changed, and that's what's useful about using an IDE to keep track of those. All right. So as I mentioned, yeah, there's this different color scheme: green for new things, yellow for modifying, and red for deleting. And then you can click on individual files then to see what's changed in that file. In this case, it's kind of weird because everything, the whole line, the whole file has changed. But in other cases, you would have, here we see the line twice because essentially it's showing in red what was there before, in green what's the new thing, and in another file, if you didn't change any other lines, they would just appear once, essentially, without any highlighting. And if there's a change that you don't like, this is the other nice part of the ID, you can click on this kind of backward arrow to undo changes. Okay, so now we did this first step, which was making edits. Now let's see, how would you do these next 3 steps from VS Code? So the adding, essentially this is saying, maybe I've changed a bunch of files, right? And the purpose of adding is essentially to select which changes I actually want to push. So maybe there's a file that's I don't feel like it's ready to share, or maybe I'm just using it to test different things. Maybe this new file is just for me to kind of test things, and I don't really mean to push it. One option could be that I put it in the git ignore, so I just don't see it there. Maybe I don't, and it shows up there. But what I'll be doing now on this adding stage is I'm going to click on this plus to add the files that I want to, kind of what's called stage for this commit. Can discard changes and visual lines. So when I click on that plus, it will become staged. So it now falls under this new category. Before there was just this changes, now they're staged. So Python has moved categories, python.py. But then I can always press the minus button, kind of doing the opposite of plus, to unstage it. Okay, so that's how I'd add a file. I could also do the same for the others too. Even deletions, they can be added. That kind of sounds like an oxymoron, but yes, deletions can be added. So that's how you would add new change deleted files. Now let's see this part about commit, which is now I'm going to kind of associate an ID and a message to this change. So in VS Code, there's this little text box where essentially I can type my message. And usually you'd want to use something descriptive to say, okay, what you've done in these changes. So in this case, I've updated the print message. So, and typically we use the present tense, which is why I said update to print message. And then, so here I put some tips, kind of guidelines on how you would phrase these things. But after writing that message, you can then press commit. And then to push, now it comes all the way like at the bottom of the IDE. There is this kind of circular, there's like this wheel, these arrows that are going in a circle. So you can press on this to kind of synchronize your project. So this would push. And likewise, if you needed to pull some changes, so you haven't made any changes, this is the button you could use to then synchronize your project and pull anything that may be on the remote computer that your colleagues may have pushed. And then in this bottom part, we can see kind of the history of changes that's been happening. So then a pop-up will come up. This action will pull or push. You can press OK. And then in this left-hand side, we'll see that, okay, the other changes that we haven't added, they're still under changes because we didn't put them to a commit and we didn't push them. So those are still there, but python.py has changed. And if we wanted to kind of undo all those changes, then we can press this backwards arrow for all of them. Any questions on this? Yeah.
You have to include a message to push.
I think you have to.
Yes.
Yeah. It's kind of one of those things where they push a good habits too on you. But often people will just say, update, update, update. I've definitely done it.
Something else about this, once you're working in more professional environments, you will be asked to use something called conventional commits. So often if you look at popular repositories with like lots of things on it, you'll see that the commit names are not like updates or like hash or whatever. It'll be something fix, and then under parentheses, like a small description of the fix. And this is called conventional commits. You can look it up. I don't know if that's the link that you had before with the guidelines.
I don't think so.
But you can look it up. It's a good habit to learn how to use them. It just allows you to have a convention for your commit messages that everyone can know and understand. It's not a requirement, but it's good practice.
Yeah, even if you do the add, update, bug fix type thing, GitHub will see a feature which allows you kind of to clean up. Let's say you did 100 commits. There's a way you can clean it up nicely through GitHub and something called pull requests. So we'll see that in a bit. So I still do those messy commits and then I clean it up later. Yeah.
A quick thing, say you made two changes that are completely different, but you're pushing them in the same commit.
Yeah.
Is that like not a conventional thing to do?
Yeah, it's better to do smaller commits rather than doing huge, changing thousands of lines of code in a single commit. But most of the time, people just group things because they don't keep the habit of committing often. But I would say conventions to do smaller stuff, right?
It's like usually it's like one feature. Don't do like one function, I commit, I bash, but just go like one feature, one general feature that may include a couple of files or whatever. One commit.
All right, and now just to kind of give the full picture, if you want to do it from the command line, just so you see how you do that if you didn't have something convenient like an IDE. So you could use something like git status to kind of see that same breakdown of files as we saw before to see, okay, what files have changed. You can then do git diff to see just what are the differences. And then those three steps that we saw before would be git add Python, git commit, putting the message, git push. And if you want to remove any changes, git restore specific file. So, and yeah, a lot of these, let's say the more advanced ones, I would honestly Google them. I wouldn't remember. Once you start getting a habit, you just kind of get to this thing of knowing where I need to find the information for something and remembering what that information is. So,
Something else.
yeah.
Those commands, there is also the git pull, the git clone, which are really useful. Those commands are 99% of Git. But the thing is, Git has 230 subcommands, if I remember correctly. So there is a lot of things you can do about it. I recommend looking at what you can do. But this is 99% of the things you can do.
Yeah, there are plenty of Git cheat sheets you can find online. Yeah.
Do you remember the code to sort of unstage something? It's like I could never manage to do that for the terminal.
I think it's on stage, isn't there? Isn't
It's ARM, yeah.
Git resets, but ARM will delete the file.
So
I think there's git restore is also, or restore staged if you want to undo like a stage thing.
because I mean, I often what I end up doing, I have to like either remove all the changes, like restore it, but then delete all the changes I committed,
Okay.
or I can't just sort of undo it and keep the local changes I did.
I mean,
I'm not sure. I didn't look much into it, but
let me try. So say do this, and then I'm an upgraded potato 1. So we see that, okay, this file has been modified. I'll just do git add Python, git status. Now we see it's been staged. It says there's this command to unstage that file. So if I do git restore staged Python, I would still have the change, but it hasn't been staged. Yeah. Okay, I think I was here. All right, so those are the command line things. Okay, so that's how we would kind of started working locally and how we would push those changes remotely. So now let's look at some, before we're looking into conflicts. I know this is the moment you're waiting for. We're going to look at GitHub a bit, just to see different features on GitHub. There's a lot of neat things, but then also some of the way they word things may not be the most obvious. So there's this issues tab on GitHub. Who's ever posted something on issues? GitHub. Okay. What I don't like about this term is that it has a very negative connotation to it, because sometimes you're just like a request. I mean, you don't have to make such a big deal issue about it, but essentially that's kind of a place where you can make a request or also bring up real issues or bugs, but also like mention ideas that you may have to make the package better. Or what I do is like in my own projects, I will open issues in my own project just to say, okay, this is an idea I'd like to do at one point, just to kind of keep a log of those different ideas. So you can look at issues as a place to keep track of ideas and bugs. Pull requests, so we'll see this in a bit more concretely, but the high level idea is that issues is just kind of talking about what could be cool, and pull requests is, okay, let's actually try and implement this and incorporate this in the code. So this is where you can kind of conveniently compare code that someone is trying to suggest to add to this project. And then usually these requests will be done from branches. Someone will branch off from the main project. So you'll usually start off with the main branch. And then they'll want to try to kind of merge that feature, let's call it feature 1, back into the main. And that's how they'll make a pull request, which will go from feature 1 to main. Again, I find the term pull request kind of weird. I would say it's more like a push request because they're trying to push that code into the project rather than pull it. Or maybe they're thinking of it in the side of the person who's in charge of main. They want to pull that request. But most of the time, it's people trying to push their code on someone else's project. But yeah, back to branches. Essentially, this is how you would start off making the pull request, which we'll see in a bit. And a branch is kind of like this lightweight copy of the code. So as I mentioned before, GitHub is not going to actually copy everything, but just make these keep track of these differences. So branches are a way we can keep track of these differences of the similar version. Yeah.
So a lot of the things that I've noticed a lot, like that issue that you mentioned with issues, a lot of repos now, a lot of big repos, instead they are not allowing you to post issues. And instead, if you want to suggest ideas, they encourage you to use a forum feature that I don't remember what it is. There is a forum feature somewhere on the repository. And they encourage you to use the forum to suggest ideas. And if it's the case, though, it's going to be mentioned in the README. So always read the README before doing an issue.
Or look at previous issues as well too. If someone's already opened something on that, so then you can join that discussion. Or look at the pull request if someone's already tried incorporating it.
Yeah, pretty much.
So yeah, that's on this. On forking, so this is more like all of these things are GitHub features. They're not. Branch is a Git thing, but issues, pull requests are not. Fork as well as a GitHub thing. Essentially, this is making an actual copy of the code. Because right now we have this code under my username. If someone else wanted to make their own version of the code, like just completely copying, deviating, they would fork it and it would be under their username instead. Yeah, and then stars are just kind of like a social thing to like the project. Okay, so let's see on collaborative coding. So trying to use some of those features. So I show Stitch here because we're going to have a little game between Lilo and Stitch in a bit. But to add collaborators, so for now, no one else can see the project but me. So if I wanted to add someone else so that they can also look at the code and contribute to it, I would go under the settings option on GitHub, collaborators, look up the username of this person, add them, and yeah, then they would receive an invitation, which they should accept in the next 7 days. I've had this often where I've probably forgotten to accept the invitation or they didn't. And then, yeah, they should accept it soon. Otherwise it expires. But yeah, that's how you would add a collaborator. All right. Now let's see what happens when both of these collaborators try to edit the same files. So when people aren't editing the same files, Git has a strategy for essentially merging these different files. But when the same line is being edited, that's where things get a bit trickier and where we need some manual intervention. So that's where this thing called a merge conflict happens. So there's 2 cases that I could think of where it happens. Maybe there's more. One is, as I was saying, people make different changes to the same line of the same file. The other situation could be someone is editing a file and another person deletes the same file. Okay. So what I'm going to do, I'm going to simulate, or it's going to be a real merge conflict. I'm going to create a conflict between 2 simulated users by creating 2 copies of this repo on my laptop. So I'll call one of them upgraded potato v1 and the other upgraded potato v2. And then what I'll show is, okay, both of these people on these 2 projects are going to make changes to the same line, and then they're both going to try pushing that change to GitHub, and we'll see what happens. Okay, so on upgraded potato v1, and feel free to stop me if something's not clear. I'm on VS Code. Lilo, so this is where we get to our little situation here. Lilo says, okay, my name's not Eric, my name is Lilo. I'm going to change this to hello world, my name is Lilo. How are you? So then they do all the steps that we saw before. What are the 3 steps? Someone remember? Huh? Someone remember, what are the 3 steps after Lilo makes this change? Yeah? Yes, so we add the file, commit, then push. So Lilo did this. Good job, Lilo. All right, Stitch now, on the other hand. Stitch now wants to make the same change to the code. Stitch didn't update his code. He branched from the same thing as Lilo. He says, my name's not Eric, my name's Stitch. I'm going to change that. Now he's going to try the same steps. Add, commit, push. The first two will be fine, but something will happen when he tries to push. So he'll get something called a merge conflict. So it won't let him push, actually. He'll say, okay, there's been changes in the remote thing. You need to pull those first and then try to push. So he pulls and then he gets something like this. His code looks all funky and he doesn't know what to do next. So what VS Code tries to essentially, so this is one of the benefits of using an ID. VS Code tries to kind of help you in the process of resolving this merge conflict. So we'll see multiple things that happened. So we'll see now there's this new section, merge changes, and it's already kind of created a commit message called merge branch main. But then we also see our source code now has all these funky arrows and text. Does anyone know what's going on here with this file? All right, so what's happening here is it's saying there's this long string of things. And if we try to deduce, we can see, okay, between this let's say section and until that long set of strings, we see what Lilo actually put, right? We see, hello world, my name is Lilo, how are you? And this long set of strings is essentially, so I was mentioning before that when we commit, we're putting a unique ID on that change. So this is the unique ID corresponding to Lilo's change, or yeah, to Lilo's change. And here we see what Stitch was trying to suggest. So it's kind of showing the comparison of this is the line that has a conflict, and this needs to be resolved manually because Git doesn't know which one it should, I don't know what that is. I think an email, that's probably it. Git doesn't know which one it should take. So that's why it says here, current change is essentially your local thing that you've tried to do. And when you see the long string, and it could be multiple lines between here and here, that will be what someone else has already committed. And now you need to figure out, okay, what parts do I keep from them? What parts do I keep for myself? And then outside of this, maybe you just have code like normal where you don't need to touch at all. But Git is really just trying to point out to you this part. So this is not something from GitHub, but yeah, from Git, where it adds these weird things. And it won't let you push unless you remove these things around the code. Okay, so what we'll do, we'll click on that file. So there may be multiple files that need resolving. We'll click on the one that we need. And then VS Code adds this nice little graphical tool where you can either say, accept current change, which means I don't care what Lilo wrote. My name is Stitch. I want to tell the world that my name is Stitch. Or you can say, okay, Lilo, I'll listen to you, accept incoming change. That's what's stuck here. Or if you, in most cases where I find myself is, okay, maybe there's bits that I want from what that person added and bits from what I have. So that's where I would sometimes do this accept both changes. So essentially it'll keep both of the lines of code, and then I'll just manually tweak how to merge them. I forget what compare changes does, but yeah, we can see later. And
It's a visual thing where you have the current change, you have the incoming change, like separate.
okay, so maybe in the side-by-side thing, or okay, all right. So then when you click on at least one of the first three options, it's going to do the corresponding thing, and it's going to remove all these tags. So theoretically, you could already push. You could do the commit once you press one of those options, but usually you'll probably want to tweak something. So yeah, as I said, these tags need to be removed from merging, and picking one of the options will remove them. Okay, so in this case, Lilo did the accept both changes. Let's say that. And what he did is says, okay, I'm not going to say hello to the world. I'll just say hello to Lilo. So it says, hello, Lilo, my name is Stitch. So now we see that all those tags are gone. So it's ready to be committed. And it still has this darker red, which means that, okay, this was the file that needed to be fixed. So we're going to press on that plus button to kind of commit this properly merged file. Okay, and then after that, we'll be able to push, and then our conflict has been resolved. Was that clear? Any questions? Okay, in the back.
Like, does the if compare exactly line by line, or is it like, for example, maybe I just have added an enter and like a new line.
Yeah.
And the rest of the files like are the same. Does it actually want me to correct like? Does it identify all of these line sheet also as a conflict, and I have to like do one by one, or it like identifies that it's not that something that doesn't actually impact it?
Usually it does a really good job at already merging most things. It will just really point out the two bits of the lines where both of you edited. So if it was just a line shift, like a new line, you said, if it was a new line, I mean, that would just be, that's just one line in your new file that would be added to your project. So I don't see why it would have a conflict in the whole file.
It would have a conflict because
Okay.
it doesn't know exactly how it can merge it properly because it's not like intelligent, like it's just numbering. That's where the compare changes thing is good. Is that you can have VS Code is going to show you each individual part where there are conflicts in the file, like in any file, and you can just browse through them. And every time you can see what's right now, what's causing the first conflict, and then you can manually tweak it for every section. So like you don't look at it in one go, you look at it piece by piece. So you can manually edit this however you want.
But it won't highlight all of your changes, only the ones that conflict with that other person.
Yeah, it's that like that line there it conflicted because well it was only one line and we tried to edit that line twice into different branches and we tried to merge it. What change do we keep? We don't know. That's for you to decide.
All right, any other questions? All right. So that's, I would say, usually the most challenging thing for people to deal with when they come with Git, but that's why I really recommend, I don't know if I have Avril Lavigne coming up again, but make your life simple and use an IDE to help visualize these changes. And then, yeah, to have these graphical buttons and tools to then merge them in a more convenient way. So yeah. So usually when, so the next thing we'll talk about is now this pull request. So this tab that I mentioned on GitHub. So this is the typical way that people will make changes to code to avoid conflicts while they're trying to implement new features. So to just recall, so the idea of pull request is we're going to branch off from, let's say, a stable version of the code, and I'm going to make my changes. The issue is that if we're all working on the main branch, and we're doing very different features which maybe overlap with each other, we're constantly having conflicts. So the idea of branches is, okay, let me just separate from the rest of the group for now, and let me just do my thing, and then when I'm ready, let's merge it. Because you don't want to have to try to figure out all these conflicts while you're also still trying to debug why your code works or doesn't work yet. So the process when you're making changes to code would be, okay, I'm going to branch. So we saw on GitHub how to make a branch. From VS Code, you can also create a branch graphically by clicking on the main. So actually the bottom left corner is telling you what branch you're currently at. Click on that. You can then create a new branch. You can name it there in the top text box. And then when you've completed that, you'll see that, okay, this new branch now has been created, and it will be indicated in the bottom left corner. All right. So now let's try to make another change to our greeting. Stitch kind of woke up with a lot of energy today, so he's going to add an exclamation mark. Hello, Lilo. My name is Stitch. How are you? So now we again see this one change that's made to a file. It's become yellow, and it's come up in this situation where we can click on this plus button. So now we're going to push this change. But what happened is, since we created this branch locally, the remote server, so GitHub in this context, doesn't know that this branch exists. So actually, instead of seeing commit or push, or you'll see publish branch instead, because this branch has to be created remotely for tracking purposes. Any questions on that? I threw in a lot of technical terms there. Okay. So yeah, at the same time as pushing the code, I've created this branch on GitHub, essentially. And one of the neat features of GitHub is that on the GitHub website, it will notice that, okay, this new branch has been created. Do you want to compare your changes with the main branch and create a pull request. So let's say in this case I do, because I want to change the main code. So what you would typically do when you click on that button is that you would have this kind of form where you can give a title and also give a description about what are the changes you've made. In this case, there's only really one change, so it's enough. I'll just say in the title, but maybe you want to kind of give a bullet point list of what you've changed in the code. And then you'll go ahead and create this pull request. And really don't be afraid when you click this pull request. You're not breaking any system or breaking any software. This is really a request. And it's going to show up now to the creator of the code to decide whether or not, okay, we incorporate this change into the code. And usually when you start this pull request, you want it to be in a quite good shape already, but it doesn't have to be perfect. Because what's nice now is from this pull request tab on GitHub, this is now where you can now discuss about the code, say, okay, actually it would be better to have this change, and you can add more commits on the pull request. So just because you made the pull request doesn't mean you can't change things after. You can still change things afterwards, is what we'll see in a bit. So when you click on that create pull request, essentially it will create an ID. So here it's the 5th pull request of this project. It's saying, okay, this person wants to merge better greeting into main. And it's going to have let's say a conversation thing where we can talk like in a chat. It's going to say how many commits are there. And then it's going to also say how many files have changed. And in this case, I'll also add someone to say, okay, can you review my code? And you can add that here, like who you want to assign to the project, who you want to review the code. So here I'll look up the username that we saw before. And yeah, so the really neat feature I like about the pull request is that instead of, let's say, what would have been maybe what I would have done in the past, which is I email files back and forth and we say, okay, this function isn't working so well. What's nice is that directly from the code, I can put a comment on specific lines of code. So let's say there's a specific line that I'm not sure of. I can say, I'll click on that plus button and I'll leave a comment directly on that piece of code. Or alternatively, the person who I asked to review my code, they can leave a comment to say, okay, I think this should have been done differently. Any questions on that? I can show an example of a current project that I'm working on. So here I've created a pull request. So here you see it's under my name. And then here we've been having long discussions on specific files. Let's see if I can find one if it hasn't been resolved, hopefully. So for example, here we were talking about something on a specific line. So this line 207 from a particular file. And then here, essentially, we kind of see this differences that would have been shown on VS Code, where we have red stuff, which is being deleted, green stuff, which is being added from 2 different versions, all the files that have changed. And yeah, that kind of shows what, let's say, the interaction on the pull request is. And then under the conversations tab, I can see all the different comments as well, too. And here, this guy was assigned to review it. So any questions on the commenting code part? Okay, so this part's really neat, which GitHub adds on top of code review. And then let's say you've completed, you have to do a few changes. So let's say in this case, I had to do 3 commits. Maybe I did 100 commits where 50 of them said update, 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 or add, bug fix, bug fix. So this is the nice part of GitHub where now I can squash all of those into a single meaningful commit message to say, okay, I added a particular added function to do this particular thing. So instead of having all those hundreds of commits, that are going to bloat the commit history. But one thing to keep in mind is if you do this option, if there was something in between that you want to get back to, you wouldn't be able to do that anymore. It's all been squashed into a single commit.
You can also do that from the command line or from, I don't know if you can do that from this code, but from the command line at least, if you haven't patched the changes, you can do it, get squashed to merge commits together into one commit instead of, so like you just push one commit instead of like 200 in your boss time.
Yeah.
After you squash, you can put more commits on top of that.
So when you do the squash, it's essentially going to close the pull request. So, but then you can always make a new one and add new commits on top of it.
Yeah, it's basically you're taking multiple commits and putting them into one. So you can add more comments.
What about the message? Because people put together.
So it will ask you, yeah, what for a new message. if you want. And then under by default, what it'll do is you'll put all of the messages below it, I think, and then you can put one global message for that whole thing. Do you want to check if they called or anything? Should be around now. Okay.
I'm getting the messages.
Okay, cool. All right. So this would be kind of the process if you're working with a collaborator on that project. So what we're going to look at now is either someone else wants to collaborate, but you don't know if you fully trust this person. So you don't want them to make whatever changes they can, because right now the guy added that I showed you, he could just merge the pull request himself. So that's one case where where someone else wants to contribute your code, or maybe what's probably more common as you're starting out now is that you see an open source project, let's say PyTorch, for example. How many of you use PyTorch or TensorFlow? So PyTorch is not going to just let you create pull requests and merge it when you want. What they're going to typically, what an open source project is going to ask you to do is they're going to ask you to make a fork. So we saw this option before. They're going to ask you to make a fork of that, which is a copy on your GitHub project or your GitHub account, make your tweaks and open a pull request from your fork. In this case, we opened a pull request from a branch in the same project, but you can also do the same thing from forks. That's what we'll see in a bit. So this workflow, so this is like kind of where you don't have write access or someone else doesn't have write access. The one I would recommend is you make a fork of that project. Another thing that a lot of people don't do, but this is my opinion here more, is that you keep the main branch as it is. Don't touch the main branch. You branch from the main with your feature. You clone your fork, which means download your version, not the one from PyTorch Meta's account, but your version. You switch to that branch you've made, or you make the branch locally, and then you make a PR from your forks branch. And the reason I say this, I think it comes up in the slide, is because let's say PyTorch makes a huge change and you need to incorporate this into your project. If you made some changes which make conflict with that, the reason you should do this setup is that you want to keep your main branch clean so you can easily synchronize your main branch with PyTorch's stuff. And then on your, let's say, thing that you're trying to develop, then you try to merge with your project's main and your branch, so that your main is kind of always just like a copy of the original source. And then you can manage conflicts in your own repo rather than when you try to do the pull requests, where it can get a bit nastier. Okay, so Stitch was still a bit confused, so he wants some pictures. So how would you do this? So for example, if you wanted to fork the project that we're going to look at next week, it's this PyDev tips, you'll click on fork. Right now it's under my username, eBesm. Here I'm forking it to the LauzHack account. So it'll be now, instead of cloning from eBesm Python dev tips, you would clone, this person in this case would clone from LauzHack / Python dev tips. And what's nice is if you're looking at forks, you'll see where it was forked from. And as I mentioned, I'm going to create that branch from GitHub, or you could do it from VS Code. Here, since there's no branch for that name, it'll give you this option to create it, clone it, as we saw before. Make sure you pick the one corresponding to your username, not, let's say, PyTorch's version. If we continue with the PyTorch example. And then locally, we just make sure that we switch to that branch so that we don't do these changes to the main and have it out of sync. So I gave this example. Let's say if PyTorch made some changes, or in this case, I made changes to the original PyDev tips. So GitHub gives a nice graphical way to now synchronize that main branch. So let's say I go on the fork, I'm in the main branch, and GitHub detects, okay, you're 5 commits behind, or 5 updates behind from the original source code. And so what GitHub provides, is this sync fork option, still drop down, where you can then click on update branch. That will synchronize your main, and then you can do the same thing of merging the main into your branch so it's up to date. Any questions on that part? So kind of the goal of this is to kind of exploit GitHub's graphical tools to kind of synchronize, to kind of to contribute to another project. So we fork it, create a branch, and then if we're out of sync, then we can use this option to synchronize with the original source code. Yeah.
We make it to request and like between the time that they decide to like look up on my request, they make some new changes. They will like get it back to me and say like, okay, apply it, and then they can adjust it.
No, so that's the good thing about the pull request is when you update your branch, you don't need to create a new pull request. It'll be done in that same pull request. So what they'll typically say is, oh yeah, we updated the code. Can you just can you merge those changes and then commit them and push? And then it'll come up as, so we can see it in the other example I showed. So actually, I had a situation just like that where someone was trying to contribute to this project. Someone else had made a pull request, and then we had asked them, "Oh, can you update the code?" And then essentially, so I gave a bunch of comments, and then here you can see this merge branch where they synchronize essentially their fork, their branch. Did a few more commits to kind of address the changes I mentioned, and it was all under the same PR. They didn't have to make a new PR. Any other questions? All right. I think this is the end. Yes. So essentially, what I hope to have shown here is that GitHub, so it's one solution, as we saw, as a framework on top of Git, provides a convenient platform to host your code remotely and also to discuss it with collaborators, but also to log ideas for yourself. Important concepts are branches to prototype ideas without breaking stable code. So you can create those from GitHub, from your IDE. Issues to keep track of bugs, ideas on the GitHub website. Pull requests to actually try to contribute or create those changes and merge them into your code in the kind of, say, cautious way to kind of see what those changes would correspond to before actually incorporating them, and then to discuss it. Oh, and then that's it, actually. Any questions?
Yeah, maybe for smaller projects where you need very specific packages, is there a
Yeah.
way to like automatically set an environment? Can you collaborate with someone, or is it just a requirements file that you just insert there?
So this is perfect for next week. So next week we'll talk about this concept of, let's say you have a Python, we'll be mainly on the Python side. How would you, let's say you have all these requirements that they're saying, how would you package it in an easy way for other people now to reproduce your setup? So we'll talk about that next week. So there's many tools, like I was saying with open source, there's requirements.txt file. Maybe we quickly go over that next week, but we'll actually see more tools where you can actually make it into a package, so you can import it locally. Your thing, yeah.
Let's say that you make a branch of a repo, and then the main gets updated a bunch of times in the same files as what you're working on, and then you want to do a pull request. What does that look like on the side of like merging those pull requests? Is it the same as when you're merging conflicts like we saw earlier, or what does it look like exactly?
Sorry, I zoned out a bit. So you're making all these changes to main?
So
yeah.
Changes, other people are making changes to the main,
yeah.
but in your
the main branch, right? Okay.
Main branch,
yeah.
in your own personal branch, you also make conflicting changes.
Yeah.
What does it look like when you then when you send that pull request and the person has to merge them? What does it look like?
So I guess then I can show maybe this one, for example, where so there weren't any changes in main in this case. If I remember correctly, when you do if there's a conflict, I'm not sure if Git does the comparison. I think they won't do the comparison if there's a merge conflict. Let me ask Fan, do you know by any chance? If there's a conflict, will Git still do the comparison? GitHub?
I'm not sure.
I think it might, but it won't be as clean looking as this. So I would handle those merge conflicts locally, as we saw, where you can then see those tags.
You like to solve the conflict by yourself locally.
Yeah, and then it will show that, yeah. Otherwise, I mean, it will look something like what we saw before, where was the merge conflict.
It wouldn't solve the conflict.
Yeah, GitHub. But I think there's probably a feature where you can try to solve conflicts from GitHub directly. But it's I would say it's more I'm more comfortable doing it from the IDE itself. But essentially, this is what you would have a bunch of these things if you had this conflict between your main and their main, whoever tries to merge either way. So. Yeah.
I think this is more about your professional experience.
Mm.
Do you think it's worth doing like the GitHub certifications that they offer?
I don't even know what the GitHub certifications that are offered. Whoa, so maybe not then. But...
So like a student package.
Okay.
Free attempt to this like GitHub certification thing.
Yeah,
I'm not sure if it's like worth it to invest the time doing it or not.
I think just doing projects is probably the best way you'll learn. I mean, that's how I learned, was by just really scratching my head and try to understand where the hell is this branch or what is going on with this code. And then using graphical tools like an IDE or GitHub Desktop. Yeah, I mean, I guess the certifications could be. I guess it'll be something similar to what we've shown here. What are the different features and commands? But I'm not sure what else they show. Maybe they give more hands-on exercises than we have the time for here. But
yeah, because I mean, I'm very like you just by doing it. But then the issue that then I'm like, I know how to use it, but that doesn't necessarily know how to use it well, right? Like I think I can get by with simple projects, but as soon as we're talking about more complex stuff, then I've never had a chance to learn that properly.
Yeah, I don't think I was working mainly with researchers than software developers even when I was in industry, and yeah, I don't think anyone took the time to do these certificates. And since I came with this though, then it gave me sort of an edge, because then my manager was really impressed with these pull request features. Like, oh wow, this is really cool. And then it was much more efficient when we were trying to figure out any changes we wanted to make to the code. So yeah.
I have a question because I'm working in a field where research where people don't really use GitHub.
Yeah.
But if I'm writing some code like just for me, would you say that it's still very useful to use GitHub if you're just the only person working on it?
I do that. And the main reasons I do it is, let's say, just to back up the code. Maybe there's a problem with your computer, or you have to switch computers. That's when useful. Or if you want to keep track of different ideas, as I was saying with the issues. Even when I want to merge my code, let's say, because in research, you probably have multiple ideas of things you want to change, right? So that's where the branches and pull requests become useful. Like instead of, oh, fan, can you open the back? Instead of trying to do all those changes at the same time in your main branch, then say, okay, I'm going to explore this idea with one branch, this idea with another branch, and then creating this pull request for each of those ideas when you started to concretize them, and then merging them in when they're ready. So, I mean, my main project is this one. So, yeah, I close this one like, okay, I was just improving the documentation. It's just me with myself. I mean, there are probably things I could do in the main branch, but I still do it anyway, just to also to kind of set an example. Maybe if someone else new comes in the project, because you don't want to, it seems kind of annoying if you tell them to do something and you don't do it yourself as well too. So yeah. So I would definitely recommend still. Yeah.
Do you know any good VS Code extension for GitHub?
I don't add any additional ones, and then just that menu option they have is already useful for me. I mean, when I was, before I used VS Code, I was just using a terminal. So then, oh, this is already a nice plugin. It was kind of built in, but I'm sure there's plenty that maybe help you analyze differences more. Did you have an idea of one, or? It lends that. Okay. That's, yeah, I've heard of GitLens. I don't know what it does, but one nice thing that Copilot does is it has this like star thing where it's essentially going to generate a commit message. So if you have Copilots kind of built in, if you're lazy about making commit messages, it'll try to make one that corresponds to the changes that you've done. So. Any other questions? If not, I have some for you.